For this question, I have 5 times the square root of 4x minus 3 is equal to 15. My first step is to divide both sides by 5. The 5s will cancel out on the left-hand side, and now I am left with 4x minus 3 is equal to positive 3. I will then square both sides. This will leave me with 4x minus 3 is equal to 9. I will then add 3 to both sides, plus 3, plus 3. This will leave me with 4x is equal to positive 12. Then I will divide both sides by 4. And this will leave me with a final solution of x is equal to positive 3. Moving on to the next question, we have 4 plus the square root of x minus 1 is equal to positive 7. My first step is to subtract 4 on both sides. This will leave me with the square root of x minus 1 is equal to positive 1. I will then square both sides. And this will leave me with x minus 1 is equal to positive 1. I will then add 1 to both sides. This will leave me with x is equal to positive 2 as my final solution. Moving on to the next question, we have the square root of x plus 18 is equal to x minus 2. For this equation, I will square both sides first. On the left-hand side, the radical symbol goes away and we're left with x plus 18 is equal to, on the right-hand side, we have to expand this binomial and we will get 3 terms, x squared minus 4x plus 4. Then I will move all terms to the side that contains the x squared. In this case scenario, I will move all the terms from the left to the right. So I will subtract x. I will subtract 18 on both sides. On the left-hand side, this will turn into a 0. And on the right-hand side, we're left with x squared minus 5x minus 14. From there, I will then find the factors of this quadratic equation. Looking at this, notice that I have parentheses on both sides. I have x, and the factors will be x minus 7 and x plus 2. From there, I will then set these factors to be equal to 0. I have x is equal to positive 7, and x is equal to negative 2. I will then check for extraneous solutions. So down below, I have my first check for x is equal to positive 7. I will substitute this into the original equation. Hence, I have square root of 7 plus 18 is equal to 7 minus 2. On the left-hand side, this will turn into 7 plus 18 will give us 25. On the right-hand side, 7 minus 2 will leave us with 5. We know that the square root of 25 is going to be 5 is equal to 5. So is this statement true? Yes, it is. So hence, x equals 7 will be a solution. Let's go ahead and check x equals negative 2. Okay, for this one, we have the square root of negative 2 plus 18 on the left-hand side. And on the right-hand side, we have negative 2 minus 2. On the left-hand side, this will turn into the square root of positive 16 is equal to negative 4. But wait a second, we know that the square root of 16 is going to be positive 4. Set it equal to the negative 4. Is this statement true? No, it's not. So hence, the only solution that you have is going to be x is equal to positive 7. Moving on to the next question, question number 4. We have the square root of 4 minus 8x is equal to 16. My first step is to square both sides. This will leave me with 4 minus 8x is equal to 36. I will then isolate for x by subtracting 4 on both sides. This will leave me with negative 8x is equal to positive 32. I will then divide both sides by negative 8. This will leave me with a final solution of x is equal to negative 4. Let's move on to the next question, number 5. For this one, we have the square root of 6x plus 10 is equal to the square root of 4x plus 16. My first step is to square both sides. On the left-hand side, the radical symbol goes away, and we're left with 6x plus 10. And on the right-hand side, we're left with 4x plus 16. Now, you can solve for x in multiple different formats for this type of equation. My recommendation is to move all the variables to the left-hand side. So we're going to subtract 4x on both sides. This will leave you with 2x plus 10 is equal to positive 16. I will then subtract 10 on both sides. This will leave me with 2x is equal to positive 6. Then I will divide both sides by 2. And this will leave me with a final solution of x is equal to positive 3. Moving on to the next question, number 6, we have x is equal to the square root of 2x plus 8. My first step is to square both sides. On the left-hand side, I am left with x squared is equal to 2x plus 8 on the right-hand side. Once I get to this step, I want to move all my terms to the side that contains the x squared. In this case scenario, I will subtract 2x and I will subtract 8 on both sides. This will leave me with x squared minus 2x minus 8 is equal to 0. I will then look for the factors of this quadratic equation. So looking at this, I have the following factors. I have x minus 4 and x plus 2. And it makes sense, right? If you multiply negative 4 times positive 2, that will give you negative 8. Negative 4 plus 2 will give you negative 2. Okay? From there, I then set my factors to be equal to 0, and I have x is equal to positive 4, and I have x is equal to negative 2 for my solutions, potential solutions. From there, I will then check for extraneous solutions by substituting back these solutions into the original equation. So let's begin by checking x is equal to positive 4. So we have 4 is equal to the square root of 2 parentheses 4 plus 8. On the left-hand side, we have 4. On the right-hand side, we have 2 times 4. That gives us positive 8. Positive 8 plus 8 will give us positive 16. So we have 4 on the left, and the square root of 16 is going to be 4 as well. So this one checks out. Then we have the check for x equals negative 2. We have negative 2 is equal to the square root of 2, parentheses negative 2, plus 8. On the left-hand side, we still have that negative 2. But on the right-hand side, we have the square root of 2 times negative 2. That's negative 4. Negative 4 plus 8, that gives us positive 4. And we have negative 2 is equal to, but wait a second, we know that the square root of positive 4 is going to be positive 2. So this one does not check out. So the only solution that we have is going to be x is equal to positive 4. All right, let's move on to the next question, number 7. Now for this one, we have x minus 3 to the 1/2 power plus 2 is equal to 5. Anytime that you see this notation here with the exponent of 1/2, you have to rewrite it as the square root, okay? So this can be rewritten as the square root of x minus 3 plus 2 is equal to 5. then I will solve this the normal format, okay? Which is what? Subtract 2 on both sides. This will leave me with the square root of x minus 3 is equal to positive 3. I will then square both sides. This will leave me with x minus 3 on the left, and on the right-hand side, we have 9. Then I will add 3 to both sides, plus 3, plus 3. This will leave me with x is equal to positive 12 as my final solution. Okay, let's move on to question number 8. Same idea here. We have 2x plus 11 to the 1/2 power is equal to 5. So for this one, let's go ahead and rewrite it as the square root of 2x plus 11 is equal to 5. I will then square both sides. This will leave me with 2x plus 11 is equal to 25. I will then subtract 11 on both sides. This will leave me with 2x is equal to positive 14. I will then divide both sides by 2, and this will leave me with x is equal to positive 7 as my final solution. Okay, now for question number 9, this one's a little bit complex. We have 9 times, don't forget about that, guys. Anytime that you have a number next to a radical, it is multiplication. 9 times the square root of 2 is equal to the square root of 3x. My first step is to square both sides. Okay. Now, on the left-hand side, we have 9 square times the square root of 2 to the 2nd power, right, like this, is equal to 3x. Now, on the left-hand side, this 9 square will turn into an 81 times the square root of 2 to the 2nd power will turn into a 2 is equal to 3x. So on the left-hand side, we have 81 times 2, which will give us 162 is equal to 3x. Then I will divide both sides by 3. And this will leave me with a final solution of x is equal to 54. Okay, let's move on to the next question, number 10. For this one, we are going to square both sides first. On the left-hand side, we now have 2x over 3 is equal to 25. We then multiply both sides by 3 so we can get x all by itself. So we multiply this side by 3, this side by 3. And we see what? That the 3's cancel out on the left-hand side. We have 2x is equal to 75. We then divide both sides by 2. And this will leave us with a final solution of 75 divided by 2. We cannot simplify that any further, so leave it alone. Okay? All right, let's go ahead and move on to the next question type. Number 11, this is dealing with the graphs. Okay, so for this one, we have a function y is equal to f of x is shown on the graph. Based on the graph, what is the solution to the equation f of x is equal to 5? Now, anytime that you see this notation, f of x equals 5, you want to go ahead and rewrite it as y equals 5. Okay, now we're going to go to the table, or excuse me, the graph, and we're going to sketch a line going through y equals 5. And what we're looking for is the point of intersection with this line and the original graph. So looking at this, notice that we have a point of intersection right here at x is equal to 4. So our solution for this one is going to be x equals 4 when y equals 5. Now the next question is, what is y when x is equal to 13? For this one, I am going to go to x equals 13, which is right here. This is x equals 13, and I'm going to create a vertical dashed line, okay? Going through x is equal to 13. And I'm going to label it x equals 13. And what I'm looking for is the point of intersection. So they gave me the x. What is the y value? So looking at this, the y value is going to be 8. Okay, so let's write that down, y equals 8, and that's my solution. Let's go ahead and move on to the next question type. Now, this is a word problem. We have the time t in seconds for a pendulum to complete one back and forth swing is given by the formula t equals 2 pi times the square root of L over 9.8, where L is the length of the pendulum in meters. What is the approximate period t of the pendulum if its length is 1.2 meters? Round to the nearest second, okay? Now, for this one, they tell me what the length is. They tell me the L value, right? So we're going to label that L is equal to 1.2, okay? And we're going to substitute this into the formula. Hence, we have t is equal to 2 pi times the square root of 1.2, right? We're replacing L with 1.2, divided by 9.8. Now, when you type this into the calculator, you're going to get t is approximately equal to 2.2 seconds. But they want us to round to the nearest second. That means the nearest whole number. So looking at this, the solution will be t is approximately 2 seconds. And that's your solution. Very simple. Just plug it into the formula, substitute it into the formula, and you're good to go. All right, for the next question, we have what is the approximate length of the pendulum if the time is 10 seconds? So for this one, they give us the time. So we have t is equal to 10. So what we're going to do is substitute this into the formula. Hence, we have 10 instead of t is equal to 2 pi times the square root of 1.2 divided by 9.8. Oh, excuse me, not 1.2. We have already done that. So it's going to be L right here. That's what we're looking for. So for this one, I am going to divide both sides by 2 pi. You can definitely do this. This will leave me with 10 divided by 2 pi is equal to the square root of L over 9.8. Then I want to get to L, right? So I need to square both sides. All right. And this will leave me with 10 divided by 2 pi squared is equal to L over 9.8. Then I will multiply both sides by 9.8. And this will leave me with 9.8 times 10 over 2 pi to the second power is equal to L. Now, if you type this into the calculator, you will get L, the length of the pendulum in meters, is going to be approximately 24.82 meters. But again, they want us to round to the nearest meter, so hence we have the length to be approximately 25 meters. They want a whole number.